grab mine. All right. Okay, so this section is just kind of the last set of stuff we haven't talked about so far with probability. We're going to start with definition of a permutation. A permutation is an ordered arrangement of objects. The number of different permutations of n objects is n factorial. So we've used that already. If you guys remember some of the combination problems we were doing, I think it was like with the Dunkin' Donuts example, they were trying to make a code and we were guessing the code. And if we wanted to use all the numbers from 1 through 9, it was 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which we said was 9 factorial. It's all the different ways we can arrange the numbers of 1 through 9. So that's really a permutation. All right, so an example at the bottom here, it says the Big 12 in Collegiate Athletic Conference is 10 schools. Lists all 10 schools. How many different final standings are possible for the Big 12's football teams? Okay, so we have to figure out for each position, first place, second place, third place, fourth place, how many possible teams can fit there. So for first place, there are 10 possible teams. For second place, then, first place has already been assigned. So there are 9 possibilities. For third place, first and second place have already been assigned. So now there are 8. So on and so forth down to the last team. There is only 1 place for that guy. So in short, if you see it at the beginning, you can just use 10 factorial. The factorial symbol in your graphing calculator is under math. And I should actually, on my home screen, let me put a 10 in there first. I'm going to need that. So I'm going to do 10 factorial. I'm going to put 10 in first. If you go into math and then go over to where it says PROB, the probability menu, it's the 4th option down there. There's also a shortcut for it. I can't remember which one it is, like an alpha something, maybe it's one of those alpha F tabs at the top. I just always use this one. And then enter, and it does that calculation for you. So 3,628,800 is the possible number of ways that we can arrange the Big 12 10 football teams in order. Okay. All right. So now we talk about permutations if we have a certain number of objects that we need to arrange. So that last problem we had 10 objects that we needed to arrange in 10 places. Now we're saying, well, let's say I have, I don't know, 15 objects, but I only need to choose 4 of them and arrange those 4. The formula is going to change a little bit. In the numerator, we're still going to do a factorial. The factorial represents how many we have to choose from. So if I have 15 objects to choose from, my numerator is 15 factorial. My denominator is going to be n minus r, where r is the number of objects that I'm taking out of the group. So let's say it's 15 choose 4. I would have 15 factorial over 15 minus 4 factorial. And the notation that we're going to use here is going to be a p. So you're going to see this quite a bit. On the left is going to be the number of objects we have to choose from, and on the right is going to be the number of objects that we're actually choosing. Okay, so it says, find the number of ways to form a 4-digit code in which no digit repeats. So because we're talking about digits, how many options do we have? How many digits are there? 10. So this is a 10 choose 4 situation. We're trying to figure out the number of ways that we can order those. Okay, if we're using the formula, it's going to look like 10 factorial over 10 minus 4 factorial, which is 10 factorial over 6 factorial. Now, you can simplify this by hand. If I were going to simplify this by hand, the top is 10 times 9 times 8 times everything below it. The bottom is 6 times 5 times 4 times everything below it. What's going to cancel here?
6 below.
6 and everything below is going to cancel, which in the numerator is just going to leave me with 10 times 9 times 8 times 7, which is going to be my final answer. At any point here, you can actually type this into your graphing calculator or into a basic calculator. I'll show you how we can get the p-values later, but for right now, you can just type in either 10 factorial over 6 factorial or just 10 times 9 times 8 times 7. I'm going to be honest, when I see problems like this, I'm usually not even using this formula. If I know, like we did the code problems before, if I know I have a 4-digit code, I just start placing numbers in the code. For the first digit, I have 10 choices. For the second digit, I have 9 choices, 8 choices, 7 choices, which you can see is ultimately the calculation that we do anyway. So for the bottom one, a psychologist shows a list of 8 activities to a subject in an experiment. How many ways can the subject pick the first, second, or third activity? Okay, so how many things do I have to choose from? 8. And how many am I choosing out of that group? 3. So that would be my notation for it. You can set up the formula if you want, or you can just say 8 times 7 times 6. I have 8 choices for first, second, 7 choices for the second, 6 for the third. That's ultimately what it's going to look like. And our answer is 336. Okay. All right, so that's permutations. I would probably put on your paper somewhere for permutations, order matters. These are the problems where you're going to see first place, second place, third place, or we're selecting things and putting them in a certain position. Like I'm making a committee and somebody is the president and somebody's the vice president and somebody's the secretary and somebody's the treasurer. Okay, so if you're selecting things and people or things are being put in a certain position, that's a permutation. Order matters. Okay, now we'll talk about distinguishable permutations. A distinguishable permutation makes one look different than the other. So for example, I've got all of those letters up there. I've got my first A, my second A, my third A, my fourth A. I've got a couple B's that look the same and a C. I can arrange them 7 factorial times, but quite a few of those are going to look the same because the A's all look the same and the B's look the same and the C's look the same. So one thing we can calculate is how many ways to get a distinguishable permutation. So we start with n factorial, okay, again, however many objects we're arranging, and we divide by n1, n2, n3 factorial, where those are how many times we have objects that repeat. So let me give you an example. If I look at those letters at the top, I have 7 letters total. My A's repeat 4 times. So I'm going to divide by 4 factorial to account for all the different ways that my A's are going to be arranged, but all still look the same. My B's, I have 2 of them that look the same. And my C's, I have 1 of them that look the same. Those numbers at the bottom should add to n, and you can see 4 plus 2 plus 1 add to my 7 at the top. And then that is how many distinguishable ways that it looks different when I rearrange them, that those A's, B's, and C's can be arranged. So 7 factorial on the top gives me 50, 40. In the denominator, if I multiply 4 factorial times 2 factorial, I get 48. And then I just divide them, which is 105. Okay, so there's 5,040 ways to arrange them, but only 105 will look different. Okay, make sense? Okay. All right, so let's try this example. A contractor wants to plant 6 oak trees, 9 maple trees, 5 poplar trees along a subdivision street. The trees are to be spaced evenly. In how many distinguishable ways can the trees be planted? Okay, I'm going to start with my denominator here. These are all the things that are going to look the same. We're assuming all oak trees look the same, all the maple trees look the same, and all the poplar trees look the same. So I have 6 oak trees that all look the same. I have 9 maple trees that all look the same, and I have 5 poplar trees that all look the same. If I add all of those up, I'm going to get 20. That's my numerator. And then we divide. This is definitely one we want to use the calculator for. We don't want to type all of this stuff in by hand. All right, let's see. Oh, I got still a pretty big number. 7, 7, 5, 9, 7520. Pretty big. Make sure I typed that in right. Didn't miss a number. I think I'm okay. All right, good there? Okay, take a second with partner group, somebody near you, see if you can do the 3 at the bottom now. Okay, so how many ways can I rearrange these 9-letter words that are distinguishable? Doesn't have to create a new word, just how many can I arrange to make them all look different? Okay, and the same sort of strategy for this one. All right, let's check them. So in the first one, nothing repeats. So just 9 factorial. I have 9 things to arrange in order. For the middle one, just the t's repeat. So divided by 2 factorial. For the bottom one, I have 3 b's and 3 e's. And then you can put all the 1s at the bottom too if you want to, but dividing by 1 isn't going to change anything, so I usually don't write those. Okay. Questions on distinguishable permutations? Okay, so order matters. All right, flip to the back of your paper now. So now's kind of the other category that we can talk about when we're making selections. Combinations is the other option. And you can see the notation looks really similar. It's still N choose R, but now we use a capital C instead of a capital P for the combinations. The big deal here is that order doesn't matter. Okay, so maybe we're selecting a committee, but it doesn't, nobody holds positions on the committee. It's just a group of 5 people. Or maybe we're making a playlist out of a selections of songs, but it doesn't matter which song plays first, which song plays second. We're just selecting a playlist, and all playlists that have the same, I don't know, 10 songs are the same. All right, so formula is very similar. The only difference is now instead of dividing by just n minus r factorial, we also divide by r factorial. So we're going to get some smaller numbers here because we're dividing by more. We're taking out all those different possibilities where maybe the same 5 people are selected for a committee. But again, order doesn't matter, so it doesn't matter who's selected first, second, third, fourth, or fifth. As long as those 5 people are on a committee together, it's all the same selection. All right, so for example, a state department transportation plans to develop a new section of interstate highway and receives 16 bids for the project. The state plans to hire 4 of the bidding companies. How many different combinations of 4 companies can be selected from the 16 bidding companies? So it doesn't outright say in a lot of these problems if order matters or doesn't matter, so you kind of have to dig into it a little bit to figure that out. Here, there is no difference between who's getting a bid, right? So if the first person gets a bid and the second person gets a bid or the second company gets a bid, they're all getting the bid. They're all getting the same amount. It doesn't matter who's selected first, second, third, or fourth because they're all getting the same position, the same job. So this is a combination. It's going to be 16, choose 4. Okay, and again, you can fill out the formula if you want. I'll fill it out once for you so you can see, but most of the time we're just typing this in our calculator, and I'll show you in a minute where we can get that located at, okay? So it's going to be 16 factorial over 16 minus 4 factorial, and then again 4 factorial. So it ends up being 16 over 12 and 4, and you can type it in at this point with all the factorial symbols. So let me do that. Let's see, my numerator is huge. Actually, I'm not even going to type it in. I'll just show you right now how we can do the shortcut. This is why we don't type it in. So I put in 16 factorial, and it's like 2.09 times 10 to the 13th power. It's not pretty to like write down and try to simplify. Under that same math menu, if you go over to probability, you can see right above the factorial symbols, we've got the NPR and the NCR. I'm just going to choose the one with the C. And the graphing calculator, just all you have to do is put in the 16 and the 4 in the 2 little boxes. It makes it really easy. So 16, 4, and it'll do the whole thing for you. 1,820 is your answer. Okay. Now, you won't have a graphing calculator on the test or quiz, obviously, but it is very easy to get these on the red calculator, and I'll review with you before your quiz tomorrow to make sure everybody can find it. But in the red calculator, there is just a PRB button. And when you hit the PRB button, there are 3 selections, NPR, NCR, and the factorial. So that's all you have to do to get those 3 options up. But again, we'll review it tomorrow before it says, just make sure you can find it okay. So you will have those at your disposal. Manager of accounting department wants to form a 3-person advisory committee for 20 employees. How many ways can the manager form this committee? Again, we're making a committee. People don't have certain positions. Order doesn't matter. So 20, choose 3, and you can just type it in your calculator. It's fine if you want to use the combination option under probability. So let's see. 20, choose 3 would give me 1,140. Okay. Good on those. Okay. All right, next slide I'm just jumping over because we talked about that already, where to find all that stuff. Okay, let's go to the Wendy's example. So it says in 2009, Wendy's had a takeout bag which said, we figured out that there are 256 ways to personalize a Wendy's hamburger. Luckily, someone was paying attention in math class. Assuming there are 9 topping options, is this correct? Okay, so this is where combinations can get kind of interesting because it doesn't say how many we can choose, right? When you order a burger, you're choosing how many toppings you want. You can get it plain, no toppings, or 1 topping and you can pick any of them, or 2 toppings and you can pick your combination of the 2, 3, 4, all the way up to you can get all 9 toppings. Doesn't matter what order I choose toppings in. Like if I get ketchup and mustard, is ketchup on there first and mustard on there second different than if I order my burger mustard ketchup? It's the same, right? Okay, so order doesn't matter, so we're for sure using combinations. The difference here is we're going to have a lot of combinations that we're putting together. We need to consider all the different number of toppings that we can select. I can have 9 toppings and choose none of them if I choose to. Or I can have 9 toppings and choose 1, okay? Remember the word or, we add. If it's and, we multiply. Okay, so we're adding all these up. 9, choose 2, or 9, choose 3, or 9, choose 4, or 9, choose 5, or 9, choose 6, or 9, choose 7, or 9, choose 8, or 9, choose 9. All right, and then we are just going to add them all up. So this will test your calculator skills. Go ahead. I got 512. Get the same thing? So was Wendy's right? Somebody was not paying attention in math class. Okay, interesting couple things. Our book really doesn't get into this, but this is equal to 2 to the 9th power. and 9 comes from the number of toppings that I chose. That's going to be a common pattern. If you're adding up all of the combinations for a certain number n, it's just actually going to end up being 2 to the n power. What was the other thing I wanted to mention? Does this kind of look like anything like my calculus people that Mrs. Littman says a lot, like, yo, somebody, you know what I'm talking about? Pascal's triangle. That's another like application where this comes in. Okay, so these are the numbers that you might see in Pascal's triangle. So just kind of some interesting stuff, but that's really all we do with it. If you know how to do your combinations, if you can add them up, you're fine. You don't need to remember the 2 to the nth power stuff. Okay, last thing we're going to do then is find probabilities with combinations. All right, so it says find the probability of being dealt 5 diamonds from a standard deck of 52 playing cards. Okay, my denominator is all the different hands of 5 cards that I could possibly get. Does it matter what order the cards are dealt in to make a hand of cards? Order doesn't matter. Doesn't matter what I hand you first, second, third, fourth, or fifth. It's still the same hand. So we're using combinations because order doesn't matter. I have 52 cards, and I'm choosing 5 of them. That's my denominator. That's my total number of possible hands. The numerator, we're trying to figure out all the different ways that I can get 5 diamonds, okay? It's still combination because order doesn't matter, the way that I'm handed them. How many diamonds are there to choose from in a deck of cards? There are 13. And I want to know how many different ways I can get 5 out of those 13. That's all you have to do to calculate this probability. All right, so in the numerator, 13 choose 5 gives me 1,287. In my denominator, 52 choose 5, 2598960. Then we just divide them. Okay, so what I want, divided by all the different ways it can happen. And I get 4.952 times 10 to the negative 4th power. Pretty small probability. Okay. Let's look at the next one. A food manufacturer is analyzing a sample of 400 corn kernels for the presence of a toxin. In this sample, 3 kernels have dangerously high levels of toxin. 4 kernels are randomly selected from the sample. What is the probability that, bless you, exactly 1 kernel contains a dangerously high level of toxin? All right, again, order doesn't matter is how I select these. I have 400 things to choose from, and I am choosing 4. The denominator is usually the easiest part of these, okay? Now, in the numerator, there's going to be 2 different things that we're going to be multiplying together. This is going to be an AND situation. I want to choose 3 kernels that do have the toxin and 1 that does not have the toxin. Again, I use the word AND, so that's how I know to multiply. All right, so let's start with choosing the 3 kernels that do have the high level of toxin. How many corn kernels in the bunch have a dangerously high level of toxin? 3, right? Oh wait, I'm reading this backwards. On 3 have it, and how many am I choosing that have it? Just 1. I was reading that backwards. I was reading 4 and 3 for some reason. Okay, I have 3 kernels in the bunch that have the dangerously high level of toxin, but I'm only selecting 1 that does have it. Okay, so that's the high toxin group. I'll label it. I have 3, I'm picking 1. Now total, I have 400 corn kernels, and I have 4 that I'm picking. So if 3 have the high level of toxin, how many do not? Out of the 400. It's got to be 397. Everybody else. And out of those, we're choosing 3 that don't have a high level of toxin. Now notice a couple of things about how this is set up. The first part of your denominator, what you see on the left, on both of those combinations on the top are going to add to that number. Okay, all the numbers on the left add to the number on the left on the bottom. And then the same thing for the numbers on the right. Those are going to add together as well. So that's how you can make sure you're not missing anything with these. Okay, so it becomes a little more complicated when we don't have a certain one thing we're looking for, when we have multiple things we're looking for in the selection. Here, I want to select a certain number of kernels that have high toxin and a certain that don't have high toxin. So that's why we had to multiply two things together. All right, and then simplifying. So 3, choose 1. Actually, I'm just going to put the whole thing in my calculator. Let's see here. 3, choose 1 is just going to end up being 3. I know that one, but the rest of them get a little messy. Times 397, choose 3. And then I'm going to divide that whole thing by 400, choose 4. And I get 0.0295, so I'm going to say 0.030 if I round that to 3 decimal places. Okay, does that make sense? That one? Okay. So, last thing I have for you, and then you guys are done. I have a half sheet of paper exit ticket. You can work together on it if you want. Put it in the tray before you leave. When you're done with this, you may work on homework. Your 3 Math Excel from last week is due tonight. If you did not get that finished during a work day on Friday, that's your homework tonight. And then tomorrow in class, I'll give this back to you at the start, and then we will do our quiz over probabilities. Go. Cell phone motto.